Hello dear students, in this subject groundwater assessment and development. In the last class we discussed about the occurrence of groundwater, the importance and the availability of groundwater in the world and in our country India. That we discussed in the last class. So today I'll continue that chapter, that groundwater hydrology chapter, but today class mostly on quality, groundwater quality. Actually, whatever I will teach today, that is not included in the syllabus, but it should be included, because that is most important. So I'm surprised to see that that in the syllabus that groundwater quality is not included. So today class will teach only little bit on this groundwater quality, quality status of India. Okay, but it's not linked with your syllabus or in your semester exam. And before this groundwater quality, first you should know what is the organization which handles, which is responsible for this groundwater in our country. Okay, the organization that is Central Groundwater Board. Okay, so before going to quality, that we will discuss the data from where you will collect if you are to work on this groundwater. So the site is the Central Groundwater Board. Okay, in every state, there is the branch of this. Okay, so they collect data district wise. Usually the district wise, and there is different random stations are there. Okay, to collect the groundwater. And here, if you go to the left side, there are different options are there where you will get the data. Okay, quality status you'll get. Okay, and you can get the this aquifer details. There is one know your aquifer. Okay, it is it will be there in the main site. There will be one know your aquifer. Okay, the state wise, district wise, block wise you will get. Block wise, and there will be mapping system. If you click on the map, okay, the location which on which you are interested to know, that block wise or the location where you have selected, that you will get the details. Means aquifer details you will get, means the depth at which the groundwater is available, that you will get. Okay, the details is available. And here the data, groundwater data you can access here. If you click here, that groundwater quality data access. Okay, and here you can get groundwater. If you click here, the options will come. Here there is India WRIS portal where you will get stage discharge quality. Okay, stage data, discharge data, quality data, sediment data. Okay, so all the data is included here. Groundwater data. The data you can run the data here you can download. Okay, district wise data is available for this pre-monsoon period for this some specific period of 2018 and 19. Okay, so in these links, if you go through, and I suggest all of you to go through these links and to have an idea how to collect the data. Okay, so if you click this site, you will have to log in. You have to register, which takes very less time. Okay, very simple registration process is there, and you can log in and you can download. Okay, you can search the data on which basin you want means whether it is Brahmani or Poitrani or Ganga basin, any basins you want to download, that you have to search, and you have to search the stations where you want to download. Okay, everything will be available there. Okay, so I suggest to go through these links. And these are the most informative things which is required for your project if you want to work on this groundwater. Okay, come to this quality. First of all, we have to discuss this quality standards as per IS Indian standard 10500/2012. Okay, these are the standards. This is this page is on the physical parameters. On the physical parameters, physical or you can say biological parameters: order, color, pH, taste, turbidity, total dissolved solids, TDS. Okay, and there will be two limits. One is a requirement, that is called acceptable limit. Another is called permissible limit in the absence of alternate source. Okay, if there is no alternate source, okay, then we can relax these values. You can be relaxed, okay, but above this it is totally not allowed. Okay, actually it is not acceptable. For turbidity it is 1 NTU. Okay, it's not acceptable above 1, but if there is no alternative source of water, okay, whatever we have to depend upon that water, then we may relax. Okay, 1 to 5, okay, means that can be possible, means that is allowed, but allowable or permissible, but above 5, that's not totally acceptable. Okay, similarly TDS 500 is okay, 500 milligram per liter, but it can be extended to 2000 if there is no alternate, so if there is no other option. Okay, that's why it is written in the note. It's written, it's recommended that the acceptable limit is to be implemented. Okay, usually acceptable limit is implemented. Okay, values in excess of those mentioned under acceptable render the water not suitable. Okay, means the values more than 1 for turbidity and more than 500 for TDS is not acceptable, not suitable for drinking, but still may be tolerated in the absence of an alternative source, but up to the limits indicated under the permissible limit in the absence of alternate source. Okay, so above in alternate source in column 4, above which the sources will have to be rejected. If the source has this TDS more than 2000, then that source has to be rejected. Okay, and if there is no other option, then we can that 500 to 2000 to 2000 can be permissible if there is no other source of drinking water. So beyond 5000 it should not be acceptable. Okay, so these things, it's not related to a syllabus, but you should remember this. Okay, next come to this heavy metals and this chemical parameters. The chemical parameters, aluminum. These things you should remember. It's required for a lifetime, and it is required for any interview. If you go, they'll ask these things. What is the acceptable and permissible limit of different parameters? Physical, chemical. Okay, these are the TDS, turbidity, pH. These are the common things. These are the basic things we should know. Okay. Aluminum should be 0.03 milligram per liter. Okay, 0.2 up to 0.2 it can be extended. Okay, in extreme case, beyond 0.2 it's not acceptable. Ammonia, it should be 0.2, 0.5 milligram per liter. Okay, and there is no relaxation. Means in case of ammonia, it depends upon the this relaxation depends upon the dangerous of the chemicals. Ammonia is more dangerous, that's why it's not relaxed beyond 0.5. Okay, it's not acceptable. That source should be rejected. Anionic detergents, okay, barium, okay. The most important, the boron, calcium, chloramines, okay. The values for boron is 0.5. 1 is maximum, or it can be relaxed. Permissible limit. Calcium 75 milligram per liter, permissible to 200 milligram per liter. Chloramines 4 milligram per liter, and there is no relaxation. Chlorides 250, and relaxation can be up to 1000 milligram per liter. Copper fluoride, free residual chlorine. Okay, these things. Okay, copper 0.05, 1.5 relaxed permissible limit. Fluoride 1, permissible limit 1.5. Pre-residual chlorine 0.2 and 1 is the permissible limit. Similarly, iron permissible limit is acceptable limit is 0.3, and there should not be any relaxation on this as far as iron is concerned. Magnesium, it should be 30 milligram per liter, and 100 up to 100 milligram per liter it can be permissible. Manganese 0.1, 0.3 is the maximum permissible. Okay, mineral oils, nitrate, remember that is 45. It's important. Nitrate, it can be maximum 45. There should not be any relaxation. Phenolic compounds, okay, selenium, silver, sulfate. Okay, these things you should remember. The sulfate 200 and it can be permissible under if it is up to 400. Sulfide 0.05, and there is no relaxation. Total alkalinity as calcium carbonate 200 to maximum 600, it can be permissible. Total hardness CaCO3, it is 200 and 600 is the maximum permissible. Zinc, the value should be 5 and it can be extended up to 15 in if there is no other option. Okay, so 15 is the permissible limit for zinc. So all the things, these heavy metals are the chemicals, you should know the permissible and acceptable limit. Okay, because they are so important. Okay, so let's come to the okay. This is the as per CGWP, Central Groundwater Report, the iron content, okay, of different parts of India. You can see the values, the more than 1 milligram per liter. These are the points, okay, shown here, the locations where iron content is, means groundwater. I'm asking, I'm telling about only groundwater. The groundwater iron content is more than 1 milligram per liter. Here you can see in the Odisha, in these regions, in Rourkela, Chhattisgarh, okay, Jharkhand, even West Bengal, and here in the, how can I say this, Punjab, Haryana, okay, in these areas also, the iron content is very high. Here in Karnataka, Kerala, you can see. Okay, the industrial areas here in the Odisha, it is fully industrial area. In the industrial area means iron ore mines are there here in the Odisha. So here the iron content is more than 1 milligram per liter. What should be the iron? You see 0.3 means there is no relaxation. 0.3 acceptable. So if it is more than 1, means here the drinking water is not suitable. Okay, means it should not be a source for drinking water. Okay. Next is fluoride. Fluoride content, if it is more than 1.5, then it's not allowed. Fluoride is 1. Fluoride, if you see, what is the fluoride? Fluoride, if you see, it is 1 acceptable, 1.5 is permissible. Okay. So beyond these are the points where fluoride content is more than 1.5. So these points, these locations where fluoride content is more than 1.5 is not allowed for drinking water, for drinking. Okay, in Odisha, some portion you can see, and here West Bengal, you can see here Rajasthan, Gujarat. Okay, in Madhya Pradesh, some area, here Karnataka, some area, Kerala, Tamil Nadu, some area, not Kerala, Tamil Nadu, some area. So the fluoride content is more than 1.5. Next is chloride content. Chloride content, it should be less than 250, as we discussed here. Chloride should be less than 250. 250, 1000 is this permissible limit. 1000 is permissible limit. You can see the more than 1000 is the red area. This is Rajasthan area. It's not allowed. The groundwater is not allowed. Okay, it's not suitable as far as this chloride is concerned. So in these areas, these green areas where 251 to 500, if there is no other source of drinking water, that may be allowed. Okay, so this is about the chloride status of India. Next is nitrate. Nitrate, I discussed that more than 45 is not allowed, as we discussed here. Nitrate more than 45 is not allowed, no relaxation. So nitrate content you can see here. The most of the locations in India have nitrate content more than 45 milligram per liter. So which is dangerous. So groundwater is not suitable for drinking. Arsenic. Arsenic content, it should be less than 0.01. 0.05 is permissible limit. You can see here arsenic, selenium, arsenic. Okay, it is not here, arsenic. Okay, arsenic is actually 0.1 0.01, okay, milligram per liter, that is the acceptable, okay, but maximum permissible limit is 0.05, and more than 0.5 is not permissible. That source should be rejected. You can see here West Bengal, these red points here, especially in border of the West Bengal and Bangladesh, you will find arsenic content, high arsenic content, more than 0.05, which is totally not suitable for this drinking water. And in these areas here, you can see then the Bihar, less arsenic, okay, 0.01 to 0.05, okay. Actually, as far as this arsenic is concerned, totally arsenic content should not be allowed in the groundwater, okay, because arsenic is dangerous. That is a major concern, major cause for the cancer, okay. Therefore, you'll find many cancer people are suffering from cancer disease. Many people you'll find here in West Bengal, Bangladesh, okay. So many people will find suffering from cancer because the people who are depending upon the ground source, okay, groundwater source, they are suffering from this disease. Next is electrical conductivity. If you go to this electrical conductivity, as far as this permissible and acceptable. Acceptable is actually 800 mho per centimeter. It's more is a unit, okay, like ohm is mho, okay. Conductivity, opposite of this, you can say reciprocal of resistivity. Reciprocal of resistance is mho. Ohm is the resistance, reciprocal of resistivity, there is called conductivity. So electrical conductivity should be within 800 is acceptable. 2500 is permissible. Up to 2500 is permissible. Beyond 25%, 100 is not permissible. So here these are given. Here unit is mho per centimeter. There is microsiemens per centimeter. It is same unit. 1 mho per centimeter is equal to 1 microsiemens per cm. Okay, one unit value is the same. Only different names, but value is the same. So less than 3000, okay, less than 3000, in more than 3000, 3500, these reds, okay, red patches are not acceptable as far as this EC is concerned, and more than 500 is totally not, okay. So these reds are not acceptable. So electrical conductivity is not so dangerous compared to this arsenic, other heavy metals like zinc, iron. But electrical conductivity is due to salt content. That is one region, okay. But this Rajasthan, Gujarat, if you see, the salt content of groundwater is more, so electrical conductivity is more. But that should not be suitable for the groundwater for the drinking, okay. And red patches here in the Andhra Pradesh, some portion there is high electrical conductivity, and these areas are not suitable for the drinking. So this much for today class. In the next class, we will continue that chapter, groundwater hydrology, and remaining portion. Thank you so much.